So, in today's class we are going to study the relation between shearing strain, elongation strain and the compression strain. So, to derive this we will consider a cubical structure, and one such face of the structure I am going to draw here on the board. So, we will consider a front face of the cube and where the length of each side of the cube is L. So, name it so the bottom end of this face or the cube in all, if we consider, it is fixed with the rigid support, and on the above surface we apply a tangential force F, means the force along the surface. So, as we understood in the previous class about the rigidity modulus, we saw if we apply the force tangentially to the surface, then there is layer by layer shift on the surface of the cube. So, now what we understand, that the position A shifts to A dash and D shifts to D dash. And the angle made by the new position with the point B and C of the bottom surface, it is theta, which we define it as the shearing strain. To find out how much compression and elongation is been taken in the diagonal of the cube by applying the force, tangential force, will join the points AC and BD. So, AC and BD represents the diagonal of the cube. We will also join here the point A dash to C and also join B to D dash. Now, from the figure only what we understand, that the new position A dash and D dash, when we compare the diagonal AC to A dash C, we see that there is a compression in the diagonal, and when we compare BD to BD dash, we see that there is elongation in the diagonal. So, to find out how much AC got compressed and by how much quantity BD got elongated, we will drop a perpendicular AX on AC and perpendicular BY on BD dash. So, now what we can observe, that now A dash C is equal to XC and BD and BY are equal. So, this AC got compressed by AX and BD gets elongated by YD dash. So, we have to now find out the relation between the shearing strain which is due to the force which is applied tangentially on the upper surface of the cube when the lower surface is, bottom surface is fixed. And the elongation strain, which is in BD, elongation is by YD dash, and compression strain, which is by AX in AC. So now we have to find out your YD dash and the value of AX. So in short, if I explain this figure, if you consider the surface ABCD of a cube where BC is fixed and AD is free surface. Now on the surface AD, a tangential force F is applied which changes the position of surface A to A dash and D to D dash. The diagonal AC gets compressed by AX and the diagonal BD gets so the diagonal AC gets compressed by AX and the diagonal BD gets elongated by YD dash. So this what we could find by putting a perpendicular A dash X on AC and perpendicular D dash Y on BD dash. So this is a short explanation of the figure. What we could see that BY is equal to BD and CX is equal to CA dash. So therefore if we calculate the elongation strain, we know that strain is change in the dimension by the original dimension. So it will be equal to YD dash by BD and the compression strain it will be equal to change means AX and the original what it is AC. So AX divided by AC. So what we can see that BY is equal to BD and CX is equal to CA dash. So therefore elongation strain we define it as change in the dimension by the original dimension. So elongation is along BD, so change is your YD dash and the original is BD. So elongation strain can be written as YD dash divided by BD and the compression in AC is by AX. So change by original if we write, then the compression strain it will be equal to AX by AC. Now our next is to find the length of the diagonal. So if each side has length, which I have already said it is equal to L, then in triangle ABD or in a triangle B or in triangle DBC, if we apply the Pythagoras theorem, then we can find it out. The length of the diagonal BD square will be equal to AB square plus AD square, or AC square will be equal to AB square plus BC square. So, BD square will be equal to L square plus L square, and if you solve it, you will get BD is equal to AC, that is equal to root of 2L. So, we can write it as BD square will be equal to BC square plus CD square, and as length of each side is L, so it will be L square plus L square. So, this is equal to 2L square, therefore BD will be equal to root of 2L. Similarly, AC we can write it as root of 2L. So, we could find the value of BD and AC. Next, we have to find out the value of YD dash and AX. So, to find the value of YD dash and AX, we'll consider the triangle, we'll consider first the triangle DDY. Now, if you consider this triangle DDY, you see that it is DY is perpendicular, and if you consider the change what we observe DDY, so we can consider the same angle as DDB, the same angle as DDB. What is will be angle for DD dash Y? The same angle will be for D dash B. So, if we consider the triangle ADB, what we can say that this angle ADB is 45 degree. Angle ADB is 45 degree. Now, as this theta is a very small change, we can consider that this CD is overlapping on CD itself. CD dash is overlapping on CD itself. So, we can consider that as theta is very small, angle ADB will be equal to angle AD dash B. So, we can even consider angle DD dash B is equal to 45 degree. As the change is very small, ADB has angle of 45 degree, so that we consider for same as for AD dash B, so for D dash B, and so for DD dash Y. So, this angle DDY, as theta is very small, we can consider it as to be 45 degree, and we can find the change YD dash. So, we can in angle DD dash Y, we can consider YD dash is base, DY is perpendicular, and DD dash is hypotenuse. So, now if we consider the triangle D dash Y, what we can say that this angle D dash Y will be equal to angle ADB, and that is equal to 45 degree. So, in triangle D dash Y, what we can write it as cos of angle D dash Y is equal to YD dash divided by d dash. So therefore yd dash will be equal to d dash cos of angle d dash y. So this yd dash will be equal to d dash cos of 45 degree, or yd dash will be equal to d dash cos 45 is 1 by root 2. Now if we consider that the change in the position is by distance x, then yd dash will be equal to x divided by root 2. Now if we consider the previous equation of elongation strain, which we wrote change by original, that is yd dash by bd. So we get yd dash is equal to x by root 2, and bd is the diagonal, which we find the length of the diagonal is 1 by root 2 L. So therefore what we get, the final equation is x by 2L. Now, so what we get, the elongation strain is along BD is equal to x by 2L. Now similarly we can find out for compression strain. Similarly, compression strain along the diagonal AC we can derive, and it will be also equal to x by 2L. So now if we add equation 4 and 5, we get elongation strain plus compression strain. Which will be equal to x by 2L plus x by 2L, and this will be equal to x by L. Now from the previous explanation of rigidity modulus, I had explained earlier that if we apply the force on the upper surface of the cube, then change in position A to A dash and D to D dash by an angle theta. So length of the cube is L, and the change we are writing it as now x, which in the previous case we have written it as delta L. So this theta is, we have already derived in the case of rigidity modulus, that this theta is equal to x by L. So we can write now as elongation strain plus the compression strain is equal to x by L, which will be equal to theta, and this is nothing but the shearing strain. So what relation, what we can see, that elongation strain plus the compression strain is equal to shearing strain, and this is our final conclusion. What is the final conclusion? Elongation strain and compression strain, if you add it, that will be equal to shearing strain.